All right. So now we're going to look at order of operations with integers. When we looked at order of operations with whole numbers, what we saw was that we had a certain order in which we always worked or evaluated expressions that involved numbers. So the order that we saw was that we did our groupings first, which a lot of times people denote as parentheses. Then we looked at our powers or roots, and that was exponents. Then we looked at multiplication or division as it goes from left to right. Then the last thing, and I'll put that in parentheses because of that. And the last thing we looked at was addition and subtraction as it occurred from left to right. A lot of times people think of this as PEMDAS. It's very important that you understand that parentheses is any type of grouping because I may not use parentheses, or you may see an equation that doesn't have parentheses used. You may use squiggly brackets, angle brackets, square brackets to make up your own type of grouping. Put cats on the end if you want. I hate cats, so I wouldn't do that. But next would be exponents, and as we talked about before, and you'll see in the future, the exponents are going to be our powers and our roots. So raising it to a positive whole number, or taking the square root or cube root or any other type of root. For this course, you'll just be looking at second and third roots, or square roots or cube roots. It's another way of saying those same things. Then you have multiplication or division, because they really are the same operation. One is the inverse of the other, or undoing the other. So as you see occur reading from left to right, because we look at things left to right. Lastly, addition and subtraction, as you see it occur going left to right in the equation. All right, so let's start this off. First and foremost, there's no parentheses. Yay, easy. Okay. No exponents, no roots, no powers. Yay. All right, we're just down to these guys now. Pretty simple, right? And let's just read the problem out loud so that we can make sure everyone at home can see this and understand what it says. So we have a negative 9 divided by 3 plus 4 times 5. Remember the dot also means times. Minus a negative 1. Okay. Guys feeling confident? I can see it in you. See it in you. So multiplication or division, whichever we see first, as it occurs from left to right. We're going to the left. Oh, we see a division problem. Let's get that sucker done. Negative 9 divided by 3. Well, we have one negative there, so our answer is going to have a negative in it. For those of you that said that, good job. For those of you that didn't, you'll get the hang of it. Go back and review multiplication division with integers if you need to. All right, so negative 9 divided by 3. It's going to be a negative because one of these is negative, and it's only one. 9 divided by 3, it's going to be 3. So we got negative 3, and I'm going to bring everything else down. So we got plus 4 still, times 5, minus negative 1. Awesome. Negative 3 plus 4 times 5 minus negative 1. Yay. All right, we're getting there. Okay, let's see if there's any other multiplication or division that occurs in this problem when looking left to right. Well, that's addition, no. Oh, multiplication. Yay, multiplication. We're going to do multiplication then. All right, so we have negative 3 plus 4 times 5. What is 4 times 5? Well, 4 times 5 is 20. And we got minus negative 1, so I bring everything else down. So we have negative 3 plus 20 minus negative 1. Awesome. Well, let's finish this up here. Oh, there's no more multiplication and division. Yay! Let's go to the next thing. Addition and subtraction as it occurs from left to right. Let's see what happens first. So we have negative 3 plus 20. I have to do that now. Negative 3 plus 20. That means if we're at negative 3, we're going to go up 20. Or if you think of it the other way, if you're at 20 and you add negative 3, it means you have to go down 3. That's right. So if you're at 20 and you have to go down 3, that would be a positive 17. Bring everything else down. Minus negative 1. Good job. If you have some more questions about that, please feel free to email your instructor, or you can go back and review integer addition There's also those Khan Academy videos for you. And also you can just type in integer addition in Google and get lots of different results to get some extra practice with if you need it. All right. One more operation. 17 minus -1. Okay. All right. We had two ways that you can do this. How far is -1 away from 17? What does it get from -1 to 0? That's 1. And from 0 to 17, that's 17 more. So 1 plus 17, that's 18. Oh, 18. Okay. For those of you that like doing it the other way, I'll write it up here. So minus a negative. Really, we're looking at what is 17 plus -1. In other words, what's 17 plus 1? And the answer, you guys were right, it's 18. 18 is the answer. So, -9 divided by 3 plus 4 times 5 minus -1 was 18. Yay! Awesome. Happy birthday. Happy 18th birthday, whoever you are out there. All right. So, that's order of operations. But there was no exponents or parentheses in this one. That wasn't that cool, Mr. Stevens. Okay. I'll give you something that you can have everything in all that. All right. Let's see here. Okay. All right. So I'm going to do -3 squared plus 2 times 5 minus -4. Okay. Okay, here we go. There's an exponent in there for you. I know you wanted it that badly. I gave it to you. Don't worry, there's a lot more examples for you to work with as well. All right, this will be the last one for this round. So let's see what we can do here. So parentheses first. And that's a -4, just so make sure everyone can see that well. Parentheses first, we have 5 minus -4. How far is -4 away from 5? Well, from -4 to 0 is 4. From 0 to 5 is 9. So this guy must be, and we can do the other way like we talked about earlier. Change this to be a positive or plus, so 5 plus 4 still would be 9. So we get -3 squared plus 2 times 9. And yes, my 2's sometimes change from having flatness to being a little more round. Sorry about that. Just notice 2. Okay, so we have -3 squared plus 2 times 9. We are all done with parentheses. Next is exponents. Okay, so -3 squared. That's what we're looking at, right? Order of operations. This negative is in front of the 3. No, it's not. It's in front of the 3 squared. So what are you going to do first? Exponents. What's the exponent on? It's on the 3. This says -3 squared. It does not say -3 squared. Those are two different things, two different answers, two different equations, two different expressions. Do not say they are the same. Are they the same? No, they are not. Okay. And if you don't believe me, you can plug that into a calculator, plug that into Google, to an Excel sheet. You can map it out, you can draw it out. You will see that -3 squared is not the same as -3 squared. One's negative, the other's positive. Well, let's look at this here. Exponents first. So we have this negative that's just sitting out here. And the question asks, what is 3 squared? 3 squared is 9. That's right. Plus 2 times 9. Okay. We're doing well. All right. Order of operations says next would be multiplication or division. Going from left to right. Oh, there's some multiplication there. What's 2 times 9? That's right. 2 times 9 is 18. Okay. So now we have negative 9 plus 18. Negative 9 plus 18. So if we're at negative 9 and we go up 18, or if we're at 18 and you add a negative 9, meaning you go down 9. The second one's probably easier to think about. If you're at 18 and you go down 9, you will get a positive 9, which I told in another video as a joke. It means no. Because I don't want you to think that's negative 3 altogether squared. Because it's not. It's negative of whatever 3 squared is. All right? That's why I wanted to make sure I did this example for you. So, order of operation, same as it was with the whole numbers. Order of operation will never change. Sometimes people think things are harder because they see a negative involved or a fraction involved. Fractions. We'll see fractions soon enough. And you're going to conquer them. And you're going to leave this class. You're going to leave this saying, you know, negatives and fractions, they aren't too bad. I work with them all the time anyway. I'm not talking about myself. I'm talking about you. Because you do work with them all the time. You work with negatives and fractions all the time throughout your life. Many times you just don't realize it. And I hope that you have begun to see how you do so throughout your life and continue to recognize that and teach that to others as well. Well, I'll see you next time.